Okay, I have started recording. So hopefully everyone can see and hear me. Can't, let me know. My name is Payman Alami, I'm Senior Specialist with the Water Supply and Demand Assessment and In-Stream Flow section. And today my colleague Akash and I are going to talk about our demand methodology. Although I have to definitely acknowledge this was built on the backs of the works of other people. I want to actually shout out, forgive me if I forget anyone, but 5 people in particular that helped me a lot. So Sam Cole, Darren Pedroja, Jaspreet Singh, John Isburner, and Jeff Parks. I reached out to all of you with questions at various points. And there was a demand methodology that the division put together during the last drought, and without that, this wouldn't have been possible. So we just use that as our foundation and just try to automate where we can and add our own nuances to it. But thanks to everyone who helped out. It wouldn't have been possible without you. And I'll introduce my colleague Akash, and then we'll move on into the presentation.
Can you hear me?
Yeah, we can hear you.
Okay. Well, hi, I'm Akash. I'm an engineer in our section. Nice to meet you.
And I just got to shout out Akash. Without Akash, this wouldn't have been possible either, because he's a master, the best R coder that I've ever seen. So he was instrumental in making this happen. I will proceed to the next slide. We'll actually get started in earnest now. Akash, yeah, take it away.
All right. So one of the main tasks of our unit is to model supply and demand availability in a watershed. So to do that, we use DRAT, the Drought Water Right Allocation tool. So we gather meteorological data and other data sets to come up with an estimate of water availability in different parts of a watershed. Then we use quality control data from ERIMS, and we approximate the demand at different locations in the watershed. So with this information, DRAT tries to allocate available supply to water users while respecting the water rights priority system. So today we'll be focusing on the demand part of that equation and how we develop our demand data set for modeling in DRAT. Yeah, next slide.
Okay, so the next slide. So I'll talk about this, the demand procedure summary. So this is just the overall process where we start out by collecting ERIMS data, and then there's GIS preprocessing step where we identify PODs that divert from the watershed that we're evaluating. We catch errors that occur in reporting. So there's instances of people submitting duplicate reports, or unit conversions. Maybe they meant to put the values in gallons, but they put it in acre feet. So we catch those. There's instances of incomplete reporting. So maybe they give us an annual total, but there's no monthly values. And so after those corrections are made, we assign sub-basins, because the watersheds it's broken down into sub-basins. And that's the overall procedure. And then the fully detailed procedure. And oh, by the way, I just want to add, so if you guys, I know there's probably going to be a ton of questions, so just ask to save those at the end, because otherwise we'll run out of time. But we'll take questions and definitely some constructive criticism at the end. So there's a pair of documents that describe the fully detailed procedure on our SharePoint. There's a demand procedure, and then there's a sub-procedure for the GIS review, which is there's a manual review. So that's laid out in the second document. And then all of our scripts are hosted on a GitHub repository called DRAT Data Scraping. And just want to emphasize, we've been using this methodology not just for the Russian River, although that's where it started, but to construct demand data sets for 10 watersheds that our unit is working on. And the beauty of it is that it's mostly R scripted, saves a ton of time, eliminates a lot of mistakes. Although there is some manual review that's required, but I'd say about 80% of the process is automated and 20% is manual. Go to the next slide. Yeah, okay. So dive into the ERIMS data gathering process a little bit. So right now there's an R script that pulls 6 different ERIMS flat files from Report Manager. And actually, I need to shout out Molly, because she helped me during this process too, Molly Williams. It made me realize that not everybody has access to Report Manager. And in the future, Report Manager is going to be replaced by Snowflake. So all our data is going to be on Snowflake. But folks who do have access to Report Manager, where like the back end of eRIM's data is hosted, we'll be able to use that R script to kind of go through our process. And then after those flat files are generated, we apply a series of filters. Probably the most important is we only look at active points of diversion and only certain types of water rights and statuses. And then I'll get into that. So that what's included, this is all explicitly mentioned in the code. And these types, we didn't come up with it. Like this was part of the division's original demand data set methodology. And some of the excluded types, which I'll get into on the next slide, are obvious. But for types and statuses that we were uncertain about, I reached out to staff who worked on the original methodology to get the reasoning behind that. So these are the types that are included: registrations, appropriatives, statements, stock bonds. And I think there's a blank type in eRIM, so we included that. A drop down. But then stuff that's excluded. So adjudicated rights, which are generally subject to a watermaster, and the reporting is done through the watermaster, not through RMS, although I've seen cases, I guess, where people do both, but we excluded those. Appropriative state filings, those are held for later use, but aren't actual appropriations. Certificates of, so for power generation, well, that's non-consumptive, and it's likely accounted for. But other water rights, we exclude those. Groundwater recommendations, methodology only applies to surface water. So we excluded those. Plus, it's only pertaining to 4 counties in Southern California. And then there's a series of administrative rights, like non-jurisdiction, and they're not really even rights, like non-jurisdictional NJs. Something that enforcement uses as placeholders and handle investigations. And then same thing with the UNs and CMPLTs. I mean, there's some records that are associated with these complaints and investigations, but face values are probably accounted for elsewhere. This is a very old type called the Section 12 filing. There's only 13 of them in the division, but there's not a lot of electronic information available. No water usage reporting, so it's hard to analyze. That was excluded. There's a temporary permit, one in all of eRIMs. Seems to deal with groundwater usage. That was excluded. And then wastewater change petitions, which aren't even water rights. So those are excluded too. In terms of statuses, anything that was active, certified, claimed local oversight, completed, licensed, permitted, registered, and blank. That was included. Everything else was excluded. So adjudicated rights were captured under other water rights, canceled. Basically, the rest of these, they're just not active. Canceled rights aren't active. Closed rights aren't active. Inactive, well, obviously not active. Pending, they'll become active, but they're not active yet. So they're diverting, it's illegal. And then rejected and revoked, we also excluded. And I want to actually make a point about inactive rights that I think Jeff Parks brought up, which I think is a really good point. So the vast majority of the inactive rights are riparian claims. And so riparians actually, sometimes they turn off or they inactivate the right, but they could, I shouldn't call it their right, but their claim, and they could actually activate it again at any time in the future. So it might be actually worth considering them because, just because they're inactive, if they become active, then that water usage history or water usage reporting history becomes relevant. And then from a longer term record keeping perspective, it'd be preferable if the people would inactivate or activate the same statement rather than file new statements, because that creates the impression that there's multiple claims where it's just one. So just wanted to have the little diatribe in there about inactive riparians because I think it's relevant. But after all those filters are applied, we jump into the GIS pre-processing step. And why do we do this? I'm actually surprised how reliable the eRIM's GIS data is, because I've looked at hundreds and hundreds of these, but it doesn't actually take much. I'd say it's based on looking at it, it's about 98% accurate in terms of how things are plotted. But I mean, if you have a few high diversion water rights that are misplotted, then that could really throw off the accuracy of your data set. So that's why we go through the points of diversion and look for 4 common misplotting scenarios. So one, PUDs that are plotted inside the watershed but actually located outside, so we remove these from the data set. Two, PUDs that are plotted outside the watershed but are actually located inside, we add those to the data set. And I guess the next two aren't really plotting errors, but you could run into instances. It's actually not that common where the PUD is plotted inside the watershed, but it actually flows somewhere else. It doesn't actually belongs to the adjacent watershed. Or the PUD is plotted outside the watershed, but it's actually hydrologically connected to the watershed. I will add this, so we didn't review every single PUD because it's just not feasible for. Oh, yes, I see Jesse's question. Yes, so anytime we notice something wrong, we went into ERMs and we corrected it. There's, I think, a couple exceptions. Actually, I think I ran into the exception where we forgot to correct something. But yeah, that's the idea. We notice it's wrong and then we correct it. But yeah, so we didn't go through every single one because there's thousands of them. So it's not enough time. It's very time consuming and laborious. So we picked a subset for larger watersheds. Smaller watersheds, we did go through every single POD. And yeah, more on that subset later. So I'll just give you one example here of something that was misplotted. So C005834 was plotted incorrectly within the Russian River watershed. You see it right here. But according to the actual certificate, belonged in Colusa County. So we removed this from the data set. And actually, I think I still have to go back and correct it in ERIMS because that's how it actually showed up when I helped put together this presentation. I was expecting it to be in Colusa, but it wasn't. So I need to go back and fix that. But in situations like this, yeah, we'd go and make the corrections in ERIMS. And then I want to just touch on this point over here about hydrological connectivity. So we used the USGS StreamStats tool to determine if something was connected or not. In addition to the water rights documentation, sometimes tell you, hey, this belongs to this tributary, which actually eventually flows into the Russian River, which flows into the Pacific Ocean. But we really relied on this quite a bit. So we type in the points of diversion or the coordinates of the points of diversion to the search box, and then we'd use the flow tool to draw a flow path. And you can see this is the end of it, the Russian River. So that's how we determine hydrological connectivity. And in terms of the stuff we flagged, Kosh will talk about, how we determined. Remember, I said there was a subset for most of the watersheds because there's just too many to go through manually. Kosh will talk about how we came up with that subset.
So this first method is how we gather PODs in the area, both inside the watershed and around it. So given the watershed boundary polygon, our script finds PLS sections that overlap with the watershed. Then it looks for PODs and ERIMs using two different checks. First, the script looks for PODs and ERIMs that have the same PLS information in their fields. So the same township, range, section, and meridian. And then second, it just flags PODs that directly overlap with these PLS sections based on their latitude and longitude coordinates. Next slide, please. Yeah, so this slide highlights some of the cases of PODs that can get flagged by this method. So in the left image, the POD that's located really far north of the watershed got flagged because its PLS fields match one of the sections that actually overlaps with the watershed. So either there's an error in the PLS section information for that POD or it's misplotted. And then in the second example, the POD is just outside of the watershed boundary, but it's located within an overlapping PLS section. So both of these cases are just important to review to double check if there are any errors. For the image on the right, if the coordinates are just slightly off, it could actually be located within the watershed. And we would just have to review the documentation to see where it actually diverts from. Next slide, please. Right, okay. So this slide shows the second flagging method. So as Paimon had mentioned, we want to review every POD, but then for some watersheds, that's just not feasible. So in this case, the script takes PODs whose latitude and longitude coordinates overlap with the watershed, and then it distinguishes between PODs that are 1 mile away from the boundary and then PODs that are more than a mile inside the watershed boundary. So this can help in reducing the workload if we assume that all PODs located more than 1 mile inside the watershed are plotted correctly. So in the image on the right, we might choose just to focus on the PODs colored in red to save time. And then the green PODs, we'd assume that they divert from the watershed and that their locations are correct. Next slide, please. And then our third POD flagging method is a text search. So given a search string relevant to the watershed, like maybe part of the watershed's name. So for example, for like Guala River, we would use Gualala, Navarro River, we would use Navarro. And with this search string, we would look in ERMs in the watershed, source name, and tributary description fields for matches. Though, because of inconsistency in how these fields are written on ERMs, the contribution of this flagging method is variable. So, for example, in the Guala River watershed, searching for Gualala in these three fields made no new contributions. Like no other PODs were flagged in addition to what was already flagged by the previous methods. And then for the Salmon Creek watershed, it had the opposite effect, where a lot of false flags came up and ended up doubling the total number of flagged PODs. That's actually what's on the image in the right. It's all those PODs, and they all seem to have Salmon Creek written somewhere in their fields and ERMs. Next slide, please. So, Pam, I think this is.
Oh, yeah, this is me. My bad. Okay, so there's some questions that we asked during the GIS review process, right? So does the report, and by report I mean the original statement, application, or other documents that are uploaded to ERMs, do they have coordinates, like on the actual PDF, that match the coordinates in ERMs? And I called those the ERMs coordinates. So the PDF, the physical thing that was scanned, we call that the report coordinates. Most of the time, it is the same. Unfortunately, the reports, especially if they're older, they don't provide the coordinates in latitude and longitude decimal degrees. So there are several layers of difficulty that we might have to sort through. For example, the report POD coordinates might be provided in degrees, minutes, and seconds, right? So then we'd have to convert them to decimal degrees and then compare them to ERMs. A little bit harder is if the coordinates are provided in northings and eastings. And then we'd have to convert northings and eastings to decimal degrees and then compare that to ERMs. We also might have to confirm the projection because northings and eastings are sometimes projected according to NAD 1927 or NAD 1983. So Kosh wrote a script that allowed me to do this, but there's also the EarthPoint website, which is what we used initially. So you can plug in the northings and eastings and then come out with the decimal degrees. The hardest, well, the second hardest, I'll get into the fifth hardest, which I guess I left off on the slide. But the second hardest is, well, what if you don't have northings and eastings at all? If the rights or the claims are super old, then they just give everything with respect to the public land survey system, aka PLSS. And then you'd have to convert to decimal degrees. And that's the hardest because you have to go into ArcGIS Pro or some mapping tool, load all the PLSS layers, note all the fields, section, township, meridian, quarter section, quarter section, even maybe, and just kind of eyeball it and see if it, is in the ballpark of the ERM's coordinate. Now, the one that's even harder, that thankfully I did not run into, but it's theoretically possible, I guess, is if they don't give you the PLSS at all, and you just have the APN, the parcel number, then you just have to see if that parcel number is close to the point of diversion. But in that case, you almost want to maybe go down to the record room and see if there's a place of use map or something else, some other thing that could keep. Is how did they come up with the coordinate errors? But thankfully, yeah, that fifth situation, I didn't run into that. But I did run into situations where coordinates were in decimal or degrees, minutes, seconds, or northings and eastings, or just the PLSS information was given. So we're going to go through a visual tour of what these reports look like. They don't always look the same. Actually, they've evolved over time. So I have highlighted on here two different reports and examples of the fields that we look at in the manual review process. I want to say that most of the time, thankfully, we don't have to look at all of these fields. They're just contingencies. So if you have the report, this is beautiful here. If you have the report latitude and the report longitude in decimal degrees, then we don't look at anything else. We just compare that to what's in ERMs. If it matches up, you're good to go. Well, I guess we might look at the report source creek and the report tributary. If for some reason this didn't say the Russian River, in this case I'm looking at the Russian River watershed, and it said I don't know, South Fork of Trinity, then I'd raise my eyebrows and I'd look into it further. So that, but beyond those four fields, if you have the report latitude and the report longitude, we don't dive into any of the other fields. The reason that you would is the report latitude and the report longitude is missing. And so then you'd have to look at the report northing and easting, and if that's missing, then you'd have to look at the quarter section, the section, the township, the range, maybe even the quarter section and the report meridian, and then just eyeball in the ERIMS. And yeah, I just provided two reports because the information is distributed differently depending on how old the report is, if it's a permit or a statement. And so I just want to give you a sense of like that. Yeah, it doesn't always look the same. So you kind of have to take your time with the report and just scour it for the information that you need. Okay, I'll move on to the next slide. So after, oh, okay, gosh, this is you.
Yeah. Okay. So we got our flagged PODs and we checked all their documentation to confirm that they're diverting from the watershed. So our GIS review is complete, and we have a list of PODs that divert from the watershed. So now that we have our water rights, we have to determine how much water they actually use. So the RMS reports are the basis for these demand values, but since they're self-reported, we have to check for different types of errors. Next slide, please. Okay, so this is the first type of error we look for duplicate reporting. Some water right holders own more than one water right. They have to submit a separate report for each water right every year. But sometimes people will report the same totals across multiple water rights reports. If they took their total usage for that year and just divided among the water rights, that's okay. But if they're just repeating the same total usage in each report, that's a duplication error. It overestimates their demand in our model then, so we have to correct it. Next slide, please. So we have a script to help with this. It flags potentially duplicate reports and puts them all in a spreadsheet. And then we manually review these records. And if a correction is needed, we specify a correction action using a standard format. Our standardized action formats are listed in that spreadsheet, QAQC action dictionary.xlsx. So we have scripts that will apply these corrections to the data set using the actions we specify in these spreadsheets. So having a standard format is beneficial then because it simplifies the process. Next slide, please. Okay, so this is an example of a duplication error. This person owns two different water rights where they reported the same total storage values in 2017. So both reports contain the same stated uses. And in 2012, this person had only one water right, and they still used the exact same values that appear in both of these reports. So then there's a good chance that this is a duplication error and not just them. They didn't probably double their usage when they had a second water right. So we mark this as keeping just one of the report records. What that action means is that when the script checks the spreadsheet and wants to remove data for one of the water rights, it'll choose the one that has the lower priority date and then zero out their data for that year. Next slide, please. And this payment year.
Yeah, so sometimes you can have a false flag. So it looks like a duplicate because the values are the same. But then if you go into ERIMS, in this case, I went into ERIMS and I looked at the water use. Had 4 pumps and literally a comment that said, look, I'm dividing the total water use by 120 pounds, which is by 4.
Payman, I think your voice got a bit quieter. It might be the mic.
Can you hear me now?
Um, it's, I don't know if it, and can anyone else hear Paymon, or is it just quiet for me? Uh,
Can you hear me now? Okay.
Yeah, there was a noticeable decrease in Paymon's volume.
Okay. Well, I'll get a headset. And then, would you like this?
Or oh, can't. Okay. All right then. So for as Pamela was mentioning that these are 4 different water rights owned by the same person, and they actually state in the report itself that they're dividing their total water usage between the different reports. So in this case, that's how we know that this was a false flag. It doesn't need to be removed then because they are displaying their water usage between the different reports. All right, so next up is unit conversion errors. So this is another type of error that our scripts try to flag. So to find unit conversion errors, so like, for example, they might be reporting, they say they're reporting in acre feet, but then they report values in gallons. And so to find these errors, we look at unusually high and unusually low values. And to help identify them, we compare reports' annual totals to a reference value. So a reference value might be like the face value or the initial diversion amount for statements. And then we also look at the median total and average total across several reporting years for each water right. And if a report's total is different from, like, well, different enough from one of these expected values, there might be an error, so it'll get flagged by the scripts. In the current iteration of our procedure, reports will get flagged if they are more than 100 times greater or 100 times smaller than one of these reference values. For the average and median totals, we also look for an absolute value difference in excess of 100 acre feet. So basically, average plus or minus 100 is the range for OK, and then it'll get flagged if it's beyond that range. Next slide, please. Okay, so just like with the duplicate reports review, our scripts create spreadsheets for us to review flagged records. And then if any records need to be corrected, we use standardized actions just like before, and for the same purpose, because our scripts will also take these actions and apply them automatically. Next slide, please. Okay, so here's an example of a record that was flagged. They reported that they used almost 68,000 acre feet in 2018. Their initial diversion amount is 0.2 acre feet, so this is almost certainly some mistake. And when we look at their RMS report, we can actually see the problem. So the values in their used column actually approximately equal the values in the direct column when we convert gallons to acre feet. So that means then what they reported as direct diversion was actually being reported in units of gallons. So then the solution is just to have the script apply a conversion factor to this report's data, converting it from gallons to acre feet. Next slide, please.
All right, can everyone hear me now?
Yeah.
All right, great. Okay, so this is an example of a false flag unit conversion. Well, I guess I kind of doubt that. Well, no, I guess the calendar year total is different, but it was flagged because the calendar year total was so small with respect to the initial diversion. But there's a couple different things going on. This is where judgment comes in. One, a lot of the initial diversion amounts are, quite frankly, they're ridiculous, okay? They're just really large because I guess people wanted to say they're using a ton of water. Two, frost protection rights, just from noticing or just reviewing a bunch of them, I noticed they fluctuate a lot. I guess that makes sense because in some years it's not that cold. You don't need that much frost protection, right? So that's an example of just judgment. You can't really automate that, I don't think, not yet anyway. So you just have to look at the report on ERIMS and look at the comments and just get a feel by just comparing different years and looking at a bunch of different frost protection rights. I looked at hundreds, like over time. And so even though it was flagged, I determined that no, this is reasonable. Unfortunately, and I haven't found a good way around this, most of the time things are false, flags, and we have to go through a bunch of false flags in order to find the true ones, but the true ones sometimes make a big difference. The other caveat that I'll add is it's like I feel like in football, you need overwhelming evidence to overturn the call on the field. So sometimes it's gray, right? Like the value, it's probably not right, especially if the person reports the same value every single month. Is it really exactly the same? Probably not, but then what would I replace it with, right? So unless like it's really egregious, I don't replace the value just because I think there's somewhere on that report where they say you have to certify under perjury or they certify that it's true. So I take them at their word unless it's just really blatantly obvious, because like I'm not in a position to just fabricate, data, right? Let's see. Let's go to the next slide.
Right.
Okay, cautious you.
Yeah. So the next issue flagged by the scripts is empty reports. So there are some reports that show up in the ERMS dataset, but they don't have any direct diversion or storage diversion data. This seems to be caused by RMS reports that have a total volume but no monthly volumes. There's an example of that right here in the slide. And since the monthly volumes are all missing, when we see the report in our data set, it just shows up as NA, which just means there's no value here for that month. So uh, when we're going to calculate monthly averages for each water right at the end, these NA values will just be removed from the averages and they won't have any influence on the final result. But since the person did submit a report, we would like to include it. In this case, even if they reported they just diverted 0 every month, that still is related to their patterns of usage, and we want that to be reflected in the averages. So just like with the other manual reviews, the script identifies these reports, and we use a spreadsheet to specify what needs to be done. Next slide, please. Okay, so after we've done all our manual reviews, it's time to incorporate all those changes into the actual data set. So to do that, we upload our review spreadsheets to SharePoint, and then we have a master spreadsheet where we write out all the file paths for each watershed. And then it's just in one script in our folder that we have to say which watershed we're working with. And then the R scripts will read that script and then read this spreadsheet to get the file paths for each watershed. And then since we use standardized actions, the code will automatically implement corrections and then make our corrected data set. Next slide, please. So at this point now, we know who diverts from the watershed and about how much do they take. Now we just need to figure out specifically where within the watershed do they divert water. So DRAT used the watershed as a series of interconnected subbasins. Based on the supply data, it models the flow and availability of water between these subbasins. And then using this demand data set, it'll estimate water withdrawals at different points and how much water is left over then. So we need to assign a subbasin to each water right. DRAT will assess that user's withdrawals based on the water availability in like the specific subbasin where they're located. So for most water rights, for all water rights, we need to figure out what subbasin they're in. And then for most of them, it's usually just the location of their POD that determines which subbasin they're in. But then some water rights have multiple PODs. And then if those PODs are in different subbasins, the process becomes a little more complicated. In that case, we do subbasin assignment using a watershed connectivity matrix and then a concept called water right splitting. For water right splitting, we'll talk about that on the next slide, but for now I want to show an example of what a connectivity matrix is. So it's a table that has zeros and ones to state how different subbasins are connected. So in this example, it's water from the row subbasin will eventually reach the subbasin that's in the column subbasin. So what that means is they're not necessarily adjacent subbasins, but eventually water from the row subbasin will reach the subbasin in the column if it has a 1 there. So subbasin B and C in this example, they eventually will flow into subbasin A. It doesn't say whether they're adjacent or not, but eventually flow will reach there from those two subbasins. But then subbasin B and C aren't connected in the same flow path. Their water flows, both of their flows reach subbasin A, but the flow in B doesn't go to C or vice versa. And then with this information in mind, we'll talk about the actual script algorithm for subbasin assignment. Next slide, please. Okay, so in the simplest case, as I mentioned before, it's just the POD coordinates for each water right. We look at that and then see what subbasin overlaps with it. In that case, we assign that subbasin to that water right. And then if they have multiple PODs in different subbasins, we first look at the connectivity matrix and check, are all PODs in the same flow path? So the subbasins that they overlap with, are they connected? If that's the case, we just choose the most downstream subbasin and assign the water right to that location. We want to maximize water availability for each water right in our modeling, and the downstream subbasin would have the greatest supply available. And then But sometimes there are PODs that aren't in the same flow path, so they're in disconnected subbasins. So like B and C in the previous example. In that case, then we use water right splitting. So the water rights split into subrights and assigned to each of the disconnected subbasins. And then their diversion data is proportioned based off the relative drainage area of each assigned subbasin. And then also we're including the areas of subbasins upstream of each of those locations in these area calculations. So we'll have examples of this too, but then there's also another case on top of that where both cases happen at the same time, meaning that POD or water right has PODs in different subbasins. Some are in the same flow path and some are disconnected. So then we have to choose the most downstream subbasins and then split the water right between them. Okay, we'll show the examples now. Next slide, please. So in this map, the green dots are all PODs for the same water right. Water is flowing in the northwest direction, indicated by the red arrow. And then since these PODs are all in the same flow path, we just assign the most downstream subbasin to the water right. Next slide, please. In that case, it's subbasin A. Okay, next slide. In this example, it's we have PODs are in both subbasins A and C, and both of these subbasins flow into subbasin B, but they're otherwise disconnected. So for that reason, we're going to split the water into two. Next slide, please. Yeah, so to divide the diversion data, we're going to consider the drainage areas of subbasins A and C, but then we also have to think about the upstream basins. So subbasin C has no upstream subbasin, so its drainage area will just be the drainage area of C. And then for the case of A, there are many upstream subbasins, so all those areas are going to get factored into this proportion. So most of the demand data for this water right will be split towards subbasin A. Next slide, please. And so after all this effort, we have a script at the end to generate a master demand table. It contains information about each water right in the watershed, and then mainly having average monthly demand values and then the assigned subbasins. This CSV file is actually an input into DRAT for their demand data. And then this table is also not static because the averages depend on the reporting years in the data set. And as more data becomes available, we have to periodically update it. And next slide, please. So far, we've already successfully applied this procedure to most of the 10 watersheds that we've worked on. Later this year, we will have to update the demand tables to include submissions from water year 2024. But in most cases, updating the data set's pretty straightforward. The scripts output new review spreadsheets each time they're run. And then if new records are flagged, we just have to review them and then copy and paste them into our main review spreadsheets that are on SharePoint. And then when we run through the scripts again, those changes will just be included in the updates to the data set. And yeah, that's pretty much everything.
All right, thank you, Josh. Yeah, so that's our presentation, and I think we'll open it up to questions for the rest of the time. I see a question in the chat from Jesse about you automatically generate the connectivity matrix. So I forget, Kosh, for the non-Russian watersheds, is that something that Paradigm is giving us?
Yes, so they're using the NHD dataset. Well, they're taking the NHD dataset and the connectivity between those subbasins as the basis for everything, for both the supply model and what we're doing for demand. But the only thing is that they modify it sometimes for their modeling purposes. Like, for example, they try and have it so that each there's not two upstream subbasins for one downstream subbasin. So it's more like 1-to-1. So sometimes sometimes it differs from what's actually in the NHD data set. Because I remember I used stream stats and then made a connectivity matrix for Navarro. And then sometimes it was differences from where they made corrections for their model purposes too.
Got it. All right. Do we have any other questions or feedback? Oh, see Abby Hill's hand raised, and then Lauren Adams. All right. Abby, you're first. Go for it.
Yeah. Hey, can you hear me?
Yes.
Okay, love it. So we are working in the permitting side, and we were really excited to learn about this effort for QA/QCing this data. But we were wondering, we see that this started back in like 2017 is the some of the earliest data that was QA/QC'd. What was going on prior to 2017, or can you tell us a little bit more about that data and why this awesome effort doesn't go further back?
That's an excellent question, and I'm glad you brought that up because I completely forgot to talk about that. It was a conscious decision, actually. So, there's a couple factors I went into. One, I think the original demand methodology for the Russian just considered 2017 through 2019. And then two, when we looked at further years like 2015, 2016, I mean, the structure of the data in ERMS was different. Like things were reported, differently. It wasn't consistent. Measurement regulations weren't in place. The data is less accurate the further you go back. So just accounting for all those differences just made it harder to, write the scripts. Plus, we knew the data was less reliable anyway. So we just decided to stick with 2017 as the starting point.
It's
Yeah.
probably the beginning of reliability for the electronic reporting. That's the transition from the old paper reporting days.
Okay,
And actually,
so
oh, go ahead. Sorry.
so how, like, we have processes that rely on data before 2017, and it's something that we've thought a little bit about, but I've been a little bit curious about how much of a difference does it make using that data before 2017? Is this like something that like shouldn't be used, or where are we at?
Maybe that's up to your discretion. I don't actually know how much of a difference it makes because shouldn't say we never included the data before 2017 to, compare, and then to go back and include it. I think that some of the scripts would have to be rewritten because I just think that the way that some of those fields like direct diversion to storage, I forget, but like the way that they're defined and labeled is, I mean, it's just different. So the scripts would have to be readjusted.
Yeah.
Damon, can I add something? Go ahead, Akash.
Oh, okay. I was gonna mention, yeah, before 2017, a lot of these water rights also had data stored in a different field called like combined parentheses direct plus storage. So at the time when we were starting out to work on it too, we were also considering out of season diversions too as something that we might flag in the data set. So then we had also decided at that time to exclude data from before then because it was a different field then and separate from direct and storage. But if we were to include the data, it's mainly just there would be more records to review, like in regards to unit conversion errors, mainly is what I noticed, but that'd be the main difference. At least with this procedure, it's possible to include more years of data, even from the past. One other reason that we decided to start from 2017 too was just we had to download more data from the flat files. So we have as a query to just download data from 2017 onwards. If we download the entire flat file, it usually just can take a really long time to get the data set, especially like water use report extended CSV. So for performance reasons too, we just said 2017 onwards. Yeah, Mom, you were gonna say something.
Yeah, just want to kind of echo what you have said. So basically, we are doing quality controlling, so cleaning up the data, but the data needs to have a minimum of qualification to be processed. If it doesn't have that minimum qualification, that then spending time and energy doesn't worth to get those kind of data. Since we are going to use all these data in a model, and a model is as good as the data that is provided to. So even if we do spend a lot of time on cleaning up those data, it's not gonna improve the modeling or even our understanding about the water demand prior to that. So I think it was around 2020, Sahil, Lang, and I did some kind of data analysis on the ERIMS data, and we realized that those data it's, before 2017 doesn't have really good qualification for accounting for any modeling. So it's we don't suggest to use data before 2017.
All right, well, great to know. Thank you so much. Really appreciate it. And it's so exciting to hear about this effort.
All right, I think Lauren was next, although I don't know if the question you asked is this, or is it the same one you have in the chat, and then Sam Cole.
My question was the same as the one I asked in the chat.
Okay, cool. Yeah, so I mean, anybody, so the repo is on the California Water Board data center, but it's private. But I mean, Akash and I are the admins, so anyone who's interested, we could give you access to it. So you could take a look at the scripts. And then, yeah, Sam, what's up?
Hey, I just wanted
Hey.
to say this is exciting. This is awesome, and good job, Paymon and team, kind of taking, I know, some very prototype level stuff and adding to it and making it look pretty polished here. So nice work, guys. This is awesome.
Thank you. I appreciate that. And thank you for all your help. You know, it wouldn't have been possible without the work that you
Yeah,
guys
absolutely.
did to get it going. So, yeah.
Yep. Been a fun long journey, that's for sure.
Yeah, that is for sure. All right, cool.
Yeah, and also I just want to commend you on your use of GitHub. Very professional, and the way we should all be doing it. I see you guys, you know, doing your pull requests, merging branches. It's a pleasure.
I mean, I don't know how we could have done it without GitHub. I mean,
Yeah,
with all the changes that we made, right?
Well,
So,
I guess you do it siloed, right?
yeah, that would really
Individually
suck.
and
Yeah.
and not in, well, yeah, siloed, not in collaboration. And but you're still going to run into version control and bugs that don't get, you know, fixes that don't get propagated to other users. So, I mean, even if we fixed the collaboration piece, you know, the way to do it is to keep an up-to-date, version controlled repository for your code base. And you guys are doing it. So I applaud you.
I appreciate you. Thank you. I see a question from Yushen. Yeah, so I'm gonna actually, I didn't realize I hadn't shared the slides. I thought I had. I'm gonna drop the link in the chat. There you go. All right. I can email it out later, and I will also, so this is being recorded, I will share the recording with everyone on the call. All right, cool. Do we have any other questions and comments? Yeah, Jesse, go for it.
Thanks, Paymon. Don't want to take up too much of the air here, but I have some folks, many of whom are on the line, working on kind of a parallel effort for the whole Sacramento-San Joaquin watershed for implementation of the Bay Delta Plan. And we're not really at the stage of doing much demand cleanup yet, but it's a lot of related things. And I'm just wondering what you think about picking up this script, applying it to some bigger or different watershed than the ones that you guys have already worked on here.
I mean, my gut instinct is go for it, man. I think, yeah, I mean, we want people to be using these scripts and making them better. And I can add you as a collaborator, yeah, to the repo.
Yeah, I'll put in the chat. I have a few staff that I think it would be good to.
Awesome. Yeah, I'll add anybody who wants to be added and have access. So yeah, that's the beauty of GitHub is you can just add collaborators.
That's a good idea, Jesse. The more the script is tested, the more reliable it's gonna be. And we did the same thing. We developed the code for a specific watershed and then tested with the pilot watershed. And right now we are testing it for the 6 additional watershed. And so far it's working fine. So hopefully works fine in the San Joaquin watershed.
Yeah, Darren, go for it.
Yeah, I guess I didn't have my camera on before. First of all, just great work, guys. But for Paymon and Akash, but potentially, I think your management, listening, and I see Mohammed. I think it's not too soon to mention maybe some of the paradigm work on DRAT, and that because we do have folks like I know Abby and JC from my section use DRAT in a permitting tool, and so I think it's getting to be the time where we might want to talk about future implementations adopting the DRAT 2.0 or whatever you guys decide to call it, and sort of retiring or archiving the Russian River GitHub repository, just so that folks start to use the new code base. I mean, there could be future implementations in other watersheds. I know you guys have sorted that out in your group, but just for anyone listening who wants to go grab a script or potentially play with this, there is some other additions to the code base coming out, and they'll be ready when supply and demand assessment kind of lets us know, but probably just like a little bit of a early flag on some of that forthcoming.
Thanks. Yeah, thanks for.
And
bringing
hopefully
that
I'm
up.
not stealing anyone's thunder or spilling the beans here, but I did want to make sure that.
No, I think it's a good thing you brought that. I
Okay.
completely forgot, but yeah. So the DRAT that I think Darren made it what it is with his team. It was originally a spreadsheet turned into the Python tool. So we'll be replacing that pretty soon with a version that our contractor Paradigm has come up with. But it's not quite ready for release yet. But yeah, that'll be coming pretty soon. And it's actually the whole purpose of this demand methodology was to come up with a demand input for DRAT. There's a supply input, there's a demand input, and then DRAT considers just the water right priority system when it makes its allocations. So yeah, the whole goal is to just get something that DRAT will take in. I see a question from Yushin. Yeah, go for it.
Raymond, thank you. Would you elaborate a little bit more on the logic of if a water right have multiple PODs, and if the multiple TODs located in multiple watersheds, and if the two watershed or the two sub-watersheds are connected, that means one will have the same flow path, and one will flow down to the another. And so you choose the most downstream sub-watersheds. But by doing that, is there a problem or is there potential issues with the priorities of the water right? Because if the other water right in the upstream sub-watershed are senior than the one that you are interested in, then, and there's not enough supply in the upstream sub-watershed, then the people would be required to, or they cannot divert. But since they are given a different sub-watershed, then it might appear that that particular water right would be able to divert because it would have a bigger supply. You know what I'm saying?
Yeah, I think so. So are you talking about like the same water right having multiple PODs, or are you talking about just water rights in different sub-watersheds, or both?
I'm talking about in one of your slides that if a water right have multiple PODs.
Oh, yes. Yeah, okay.
And how you guys decided that how to put that particular water right or assign that particular water right in a specific sub-watershed or specific sub-watersheds. And if those sub-watersheds are not in the same flow path, then you would just assign it into the different sub-watersheds. But if they're in the same flow path, I think in the slide that you said, you would choose the most downstream sub-watershed. So would
Yeah.
that create a potential issues
Go back to that slide.
Yeah, it'd be
with
30.
the different priority dates within that sub-watershed?
If it's the
If
if
go
the
back to a few more slices, or maybe I'm not.
Is this it? 33?
Go up, go up where that you have some text.
Oh, okay. I see.
should be
what-
33.
Yes.
33.
So you're saying if the PODs are in the same flow path, the most downstream watershed is chosen. So if let's say they have two PODs and one is on the upper sub-watershed and then the one is on the lower sub-watershed, but these two sub-watershed are in the same flow path. And so if the water supply in the upper sub-watershed is used out by the people, that means that demand is more than the supply, then they should not be able to divert anymore. But that particular water right, because it assigned to the downstream sub-watershed appear on the paper, then that water right will still be able to divert. Then that created an issue that even though all the other water right who might be more senior than that particular one are required to stop diverting. Do you know what I'm saying?
If there's not enough supply available for everyone, then I think first what happens is they curtail based on the priority date. So even if it's lower where there's more supply availability, first drop will remove the less senior water rights, like curtail those ones. So even if it appears more downstream, it should still be curtailed first. Payman, do you remember for sure? That's how it works, right, for chat, I think.
Akash, can you go to the slide with the split? Next slide.
Oh, I have this one. Okay.
Okay, yeah. So just to answer that, imagine a water right which is on the subbasin C has multiple PODs or even two PODs, one on subbasin C and one on subbasin A. And it has a seniority, it's the senior water right, and it can divert water. But since in the subbasin C, there is not enough water, it might be shortage for that water right if we consider only one POD for that water right. Okay, and we assign that POD to the subbasin C, then DRAT will assume that there is a shortage of the water, so that water right might be shorted. But as you know, as we follow down the basin, follow down the stream line, and as the drainage area increases, the amount of water, the amount of surface water that joins the stream flow increases. So there is higher opportunity, there is a higher chance for that water right to be able to divert water if we assign or allocated water if we assign the POD at the downstream subbasin. So
thank you, Mohammed. That's very good. Sorry, I was not able to articulate the way that you articulate. Thank you.
Okay. Great.
Well, and I think just the one note I'll add is that this subbasin process is, it doesn't suppose any existing knowledge about, the water rights or what's going on. So, to the extent, and I think, Jesse, your comment here in the chat, I think is really like indicative of this, where we do have a better knowledge of how we should split rights, based on or how we should split the reporting based on our knowledge of their rights. I think, by all means, let's use, that knowledge to make this as precise as we can. This is kind of the crude tool when we have no knowledge.
Yeah, and I would echo, I mean, Jesse, I think that a couple of years ago, a few of us took a look at the Excel Delta water availability analysis tool. And, you know, there was, I think, like a mini attempt to maybe code some of it into Python. And it's such a, like a snowflake, right? I mean, it's that I think you guys are looking at really more of something custom. However, I do think there's probably some benefit to really understanding DRAT. And I know you've got some folks from our team on your team now, so I think you've got like some of the know-how and some of the everything you need in terms of the staff resources. So yeah, I think that this is really portable to most watersheds. We've seen, you know, some growing pains, but you know, we've also implemented a couple, and the Delta is kind of its own beast. And thanks, Phil, you know, for, you know, your leadership and putting this on for everyone. And thanks again, guys.
Thank you.
Yeah, and just to echo what Darren was saying, I think one of the I guess the benefits of DRAT was keeping it modular, but also sort of fundamentally like simple at its basic levels. And so you can kind of create custom solutions for those strange nuances that you find in watersheds, like a number of them that got created, for example, in the Russian. So that's one advantage to kind of keeping it pretty like basic at that level.
The work that Paradigm is doing in creating what we're calling kind of a universal DRAT, watershed agnostic DRAT that can apply to, any of the 10, on the slides that Paymon had at the end there. So that's, really kind of the focus of that effort is to provide us something that we can, really quickly take what we've been using and developing and iterating on in the Russian and make it something that we can template out to these other watersheds pretty easily. Kind of a slight tangent, but not especially. Other staff in Mohammed's unit here are working on some visualizations of our demand data sets as well. So I think maybe at an upcoming division all staff, we might have a presentation, a 10-minute or so presentation there to kind of demonstrate the Power BI visualization there and the opportunity to actually start to show publicly, some of the visualizations of demand that are going into our allocations. And, I think the staff can recognize already that, hey, what we've been putting out through this QA/QC process is one thing. Now to actually see it and let people understand what our decision making has led us to is going to start to provide that next level of trust and understanding of what these demands truly look like.
All right, cool. All right, do we have any other questions or feedback? Okay, well, if not, sorry for going over a little bit. I'm going to release video recording and transcription, and then links to all the documents in the PowerPoint itself with an email. And then everybody who's interested in the repository, guys, email me or message me on Teams, and I'll add you all. Yeah, I'll give you I'll give you write privileges, I think. Yeah, because I mean, if you notice something's off, let us know. Yes, beauty of GitHub. I mean, it doesn't, because with the pull requests and stuff, I mean, if you end up writing something that breaks something, we can just, roll it back or not, pull it in. So don't worry about that. Okay, cool, guys. Thank you for your patience. Have a good afternoon. Bye-bye.
Thank you.